Hi, everybody. Uh, so, just as a quick background, uh, I built a few platforms that kind of scaled a lot, and through that, I done a lot of research, and I was very much into machine learning, and we did some predictive analytics that were distributed across products, isolated, the internet, and doing all sorts of cool things to optimize hot water and gas. So I was always passionate about these kinds of tough business problems and how exactly we solve them beyond going the buzz and the fun stuff that we all love. So obviously, agents, AI, and all that is like a glove into what we did. Now, the truth is, agents without data, they just generate your blog post. So that's kind of the end of it. So getting data efficiently into an agent is important if you're trying to solve an actual business problem. But we need to keep the humans in the loop. So the humans, they need user interfaces, just like the ones we're currently used to, a lot of solid platforms and stuff like that. But we need the agent in the back to do the work for us while having access to the same income, while we see the same dashboard that they see. And this is just from an operator perspective that has a job day in and day out. So to that extent, we launched a bot that connects to a series of applications who manage sales transactions, inventory, warehousing, and a few other sources of data. We pull this data from other systems, and we allow the user to give the users access to ask questions of business. Now, there were a few questions that we imagined and other questions that were asked. The question that we imagined was very specific, report type questions. The questions that were actually answered was even one word sales. So the idea was, how do we not reply back with a hey, you could say this and that, and then you would get the result you're looking for, which is always an option. You can have an agent that starts rephrasing for you, gives a few examples, and trains the user on how to use that. But what if we introduce bias and context, depending on where you are, not only in the UI, but where you are as your role in the company? What does the company do? How does it do it? And a few specific instructions written on a company level. So to that extent, we built our multi-agent framework, which is built in TypeScript. This is in our platform. We're gonna open source the code. We're cleaning it up so it's nice. We're gonna open source that part. So the router receives the user question. The router is the agent that chooses which agent should answer and why. The router then needs to talk to the query builder, and the query builder needs to figure out what types of questions to ask each one of the agents. What happens when you're building agent workflows is the more focused the agent is on one task, the more accurate the response is. The more you try to pack into an agent information about sales, purchasing, or multiple types of information, the output is going to be that bland ChatGPT obvious text. That's why that actually happens. The more you focus it on one single idea, the better the quality is going to be. So after the query builder takes in the each agent ID that is figured out by the router, this rephrases what each agent is supposed to do and goes into the agent workflow, which can contain any number of agents. The number of agents should never be 20, 30, because like we kind of wait a lot for these queries to come back. So like there's also a UX thing here. So 3 or 4 agents and like capping the router and picking 2. It's kind of enough. 3 when you're running background processes. We separated the idea of what the user asks and the question and the answer they receive versus what is generated as a report. What we call a report, what is a report in the modern day, is a really well-engineered prompt, which can run for minutes and minutes because nobody's in a hurry. It's just going to be surfaced to the user as output, PDF, or whatever you want to give to the user. That's great. So what we do is we limit the number of agents by letting the router decide who does what, and then rephrasing the same question in multiple shorter questions. And this is one of the tricks that we're experimenting with right now with different RAG models. Because running RAG on business data is not really a good idea. There's millions of documents, there's not much interesting things there. So we layered it in terms of analytics by building an analytics engine that runs configurations against the analytics engine, not pure queries. We're not crazy to run queries from the algorithm directly to the database. So in essence, what that does is it simplifies the agent work, lowers the context window, but not to be, the goal is not necessarily to be cost aware or offer fair cost to the customer in terms of token usage, but more importantly, to make it run very, very fast. Each agent has a series of tools at its disposal, and those tools can obviously be extended. Tool calling is pretty good. Put just your tool choice on auto, and it works pretty good. It's pretty reliable, even when you're doing multi calls. And then everything else goes to a formatter once this part is done. The advantage of doing it this way is that you can choose serial or parallel how you want to run the main workers. So some of the times, our two experiments were if a router routes from agent to agent and receive one response, or does the router ask all the agents and then capture the responses and puts them forward? The answer for us is to run them in parallel, not only for speed, but because the order that the data comes back from each agent is only important for the formatter. And we observed that order of agent replies actually affects output quality in the formatter. It's pretty interesting. You put it in a different way, it kind of changes the token structure, and it's pretty interesting. What it does is if the data analyst is the last to run, the formatter is going to have a bias to data analytics. If you flip it, it's going to have a bias to sales performance. So whoever runs last at the data set, that's where the bias is. Now, we didn't try to overwrite that. We didn't want to overwrite that because we want to add a randomizer as to where you put the data and just A/B test to see which are the most interesting responses we can get back. Now, this was supposed to be more color with the experience somehow. So the first part was the routing for your optimization and doing some sort of deterministic path, which can be serial or parallel. The second part was choosing the execution, but most importantly, we had to build some special tooling to do role-based access control because it is a business. Not everybody should have access to everything. But then again, we can't really prevent your question from being broader than everything. And we cannot assume that the user knows what is the limit of their data access. The third thing was domain specific and bias. The biases, we use the biases to play with roles. This is where we get to the whole multi-agent thing. And okay, here's my sales forecasting agent. Here's my inventory analysis agent. Here's my whatever. Right? So that's where we get into access validation and bias, depending on who's asked. So that makes the answer not only more relevant, but more easy for us to go down the org chart and understand. Okay, after this type of output, who should perform an approval? So you gotta go faster. So this is what happens. The router creates a stream, and then we got a chunk accumulation at multiple streams and a promise graph for the tooling. Now the tooling has internal and external APIs and services, and boom, after the stream comes through, we have here's an example of a generated graph using a forecasting service from Profit. Funny enough, it was written by an agent, the whole code. And then you got the explainer and bias to the specific role who asked this, saying that the highest revenue reported, blah, blah, blah. And then it's going to go on and talk about the products, like how to optimize their business. Now, that's what actually happens in the back. I'm just going to skip it real quick. I'll put this on Twitter anyway. So the first step is to do the agentic streams, which is the first part of the stream that returns an observable. Because it's AI, we still have to stream to the front end. Otherwise, it's a really bad experience. You're waiting there, you have no idea what's happening. Then the second step is to do all the tool calling in a specific order and choose between parallel and serial, and then return all of that stuff. Okay. Then what we do is we wrap the completion. We wrap the completion in a process from an accumulator because everything that is tool calling for analytics has a JSON response. So you gotta wait for the chunks to finish in JSON response to finish it up and then send it to data analytics. Tool calling, and then voila, at the end, we just take all the normal streams that you have in GPT or whatever it is that you're using, and that's it. The output is this. We have a series and series and series of applications, which are all AI optimized. They have a bunch of agents chatting with each other and trying to find all sorts of solutions. But every single one of these actually has UIs.